Okay, this begins section 3.2 or 3.1, I'm sorry, functions. For each of the following rules, state whether it defines y as a function of x or not. In y is equal to x cubed. Y is equal to x cubed, so y is a function of x. If I input an x value, I get y. Here, this is saying that the y value plus 2, if we take the absolute value of that, we're going to get x. So this would not be a function of x. This is a function of y, which isn't a function. The y equals, we have an x over here, so I'm going to say that yes, this one is a function. This one does define y as a function of x. Same thing here, y is a function of x. X is a function of y, so this one wouldn't be. And then y is a function of x. So this one's not, and this one's not, and the rest are. Okay, B says find f of 4, f of negative 3, f of 2.7, and f of negative 4.9. Alright, so we have in I, we're going to find the f of 4. Now because this is a piecewise defined function, I need to know where 4 is. So 4 is greater than 2, right? And this says when x is greater than or equal to 2, we're going to use the line 5x minus 7. So this is going to be 5 times 4 minus 7. And so the f of 4 is equal to 20 minus 7. So the f of 4 is equal to 13. The f of negative 3. Negative 3 is less than 2, so we're going to use x squared. So the f of negative 3 is equal to negative 3 squared, and that is equal to 9. The f of 2.7. Well, 2.7 is greater than 2, so we're going to use the line 5x minus 7. So the f of 2.7 is equal to 5 times 2.7 minus 7. 5 times 2.7 is going to be 13.5. And then we're going to subtract 7. And that's going to be 6.5. So the f of 2.7 is equal to 6.5. The next guy says the f of negative 4.9. Negative 4.9 is going to be less than 2, so we're going to use x squared. So this is going to be 4.9 and negative 4.9 squared. And a negative times a negative is a positive, so the f of negative 4.9 is equal to a positive 24.1, or 24.01. Moving down here, the f of 4 in 2 is going to be, f of 4 is equal to, okay, so where is 4 in this bunch? Equal to 4, here it is. So we're going to use x plus 1 if x is greater than or equal to 4. So the f of 4 is going to be 4 plus 1, and that's going to be 5. The f of negative 3 is going to be less than 1. So if x is less than or equal to 1, we're going to use this negative 2 times negative 3 plus 4. This is going to give me positive 6 plus 4 is 10. So the f of negative 3 is equal to 10. The f of 2.7 is equal to 2.7 is in between 1 and 4, so this says f of x is equal to 3, no matter what x is, if x is greater than 1 or less than 4. So 2.7 is in between 1 and 4, so it said that f of x, no matter what it is equal to 3. And the f of negative 4.9 is going to be less than 0, or less than 1, sorry, so we're going to use this, this top one. So we get negative 2 times negative 4.9 plus 4. Negative times negative is positive. 4.9 times 2, 9.8 plus 4, so 13.8. And that's the f of negative 4.9. Alright. So I think that was it for those. Okay, so I wants us to find, for each of the following, find f of 4p, the f of negative r, the f of m plus 3, and the f of negative 4.9. So let's do, so this is our function. F of x is equal to 6 minus x, and A wants us to find the f of 4p. That's going to be equal to, we're going to substitute x with 4p. So this is going to be 6 minus 4p. B wants us to find the f of negative r. And that's going to be equal to 6 minus negative r. And we can simplify that a little further and get 6 plus r. Or r plus 6. However you want to write it. And the next one wants us to find the f of m plus 3. Now remember, this is the quantity m plus 3, and this whole thing is going to go into this x value. So the f of m plus 3 is going to equal 6 minus the quantity m plus 3. And then we can simplify this. This is going to be equal to 6 minus m minus 3. And then we can simplify that, and 6 minus 3 is 3. So we have a negative m plus 3, or, oops, what did I do there? So we have negative m plus 3, or 3 minus m. Either of these would be a solution. Let's see. Now we need to find the f of negative 4.9. So the f of negative 4.9 is going to equal 6 minus negative 4.9, which is going to be 6 plus 4.9, which is going to be 10.9. In the next one, we're asked to find the f of 4p in the function the square root of negative 2x. So I'm going to replace this x with 4p, and then simplify. So the f of 4p is equal to the square root of negative 8p. Now, yeah, I'm not even going to go into anything like that. Just, we'll leave it like that. For this level of mathematics, I think it would be more appropriate to find the f of negative 4p. So I'm going to do that. The f of negative 4p is equal to the square root of negative 2 times negative 4p. So then we're going to have the f of negative 4p is equal to the square root of 8p, which I can then rewrite as f of negative 4p is equal to the square root of 2 times 4 times p, or the square root of 4 times the square root of 2p, and that's going to be equal to 2 root 2 times p. There we go. Alright, so then it asks us to find the f of negative r. So the f of negative r is going to be the square root of negative 2 times negative r, and that's going to be the square root of 2r. So we have the f of the quantity m plus 3 is equal to the square root of negative 2 times the quantity m plus 3, and then we simplify, we get the square root of negative 2m minus 6. The f of negative 4.9. So the f of negative 4.9 is going to be equal to the square root of negative 2 times negative 4.9, and that's going to be 4.9 times 2, 9.8. I feel like I already did that once. I think I did. Equals negative times negative is positive, so it's going to be a positive 9.8. And the last set, we have the f of 4p is equal to negative 1 over 5 plus 4p. F of negative r is going to be equal to negative 1 over 5 plus negative r. And then I'm going to want to simplify this. So what I can do is I have this negative 1 over, I take a negative out, so I'm going to get a positive r and a negative 5. And then these would cancel. So that's going to be equal to 1 over r minus 5. And just to be clear, in case we got lost, if I start with this function, negative 1 over 5 plus negative r, and I rewrite this is equal to negative 1 over negative r plus 5. So this is a positive 5, this is a negative r. I didn't change anything. And then I took the negative out, so this is going to be negative 1 over negative times negative gives me a positive r, and negative times positive gives me a negative, and then the 5. And that's how I cancel. Alright, let's see, the f of m plus 3. So we're going to have negative 1 over 5 plus the quantity m plus 3. There's nothing in the parenthesis that I need to do, so I can drop them. So I get negative 1 over 5 plus 3 plus m, and that's going to be equal to negative 1 over 8 plus m, or negative 1 over m plus 8. And the f of negative 4.9 is going to be equal to negative 1 over 5 plus a negative 4.9. I'm going to rewrite this as negative 1 over 5 minus 4.9, and that's going to give me a 0.1. Negative 1 over 0.1, and then I'm going to multiply the top and the bottom by 10, or yeah, that's what I'm going to do. I'll multiply the top and the bottom by 10, and I'm going to get negative 10 over 1, and that's going to be equal to negative 10. So the f of negative 4.9 is equal to negative 10. Alright, so D says for each of the following functions find the difference quotient. And that is going to be the f of a plus h quantity minus the f of a divided by h. So we have the function f of x is equal to 2x minus 4. And we're going to take the f of a plus h, and that is going to be 2 times a plus h minus 4. And we take the f of a, which is going to be 2 times a minus 4. And then the formula says it's this guy. This is the f of a plus h. So we take 2 times a plus h minus 4. And then we're going to subtract the f of a, which is this guy. So 2a minus 4. That looks like a 9, doesn't it? Over h. And then we're going to simplify. So I'm going to distribute this 2 through. So this is 2a plus 2h minus 4. And then I'm going to distribute this negative sign over here, and I'm going to get negative 2a plus 4. And we're going to divide this by h. And then we're going to go through, and we have a positive 2a and a negative 2a, so those cancel. We have a negative 4 and a positive 4, so those will cancel. And I'm left with 2h over h, and the h's cancel. So the f of the difference quotient is going to be equal to 2. So equals 2. Okay, so I'll write the formula up here again. F times a plus h minus the f of a. And I think if she asks us this, she's probably going to have this on the test. If she doesn't, just memorize it. So the f of a plus h is equal to a plus h quantity squared minus a plus h. And the f of a is equal to a squared minus a. So again, we're going to take the f of a plus h squared minus the quantity a plus h, and we're going to subtract this f of a, so a squared minus a, and then we're going to put that over h. And now we're going to, this is a plus h times a plus h, so I'm going to get a squared plus 2ah plus h squared minus a minus h, and then this I'm going to distribute the negative, so I'm going to get minus a squared plus a all over h. And now I'm going to run through here and do some cancellation. The a squareds cancel, plus a minus a, and then I'm left with, I'm going to reorder this in descending powers, so h squared, that's a positive 2ah, and then a negative h, all over h. And notice that the h is common everywhere, so I'm going to cancel the h's, and I guess I should I'm going to factor it out first, just so maybe for some people it won't make sense. So I'm going to say h times h plus 2a minus 1 all over h, and then see the h cancels. You could do it from here, but notice that when you do it from here, there's an h common to each term. So this h goes with this h, but that h goes to 1, and then this h, and then one of those h's would cancel, and you'd be left with h plus 2a minus 1, which is what we have here. And so the difference quotient for this, the answer is going to be h plus 2a minus 1. And that concludes chapter 3, section 1.